Hello everybody and welcome from Seattle, Washington. My name is Chris Melisinos and I'm the Principal Evangelist for Video Games here at AWS. And I'm super excited to be here at one of our offices where we're hosting a WebXR Hackathon with AWS partner Meta. Over the next few days, I'll be interviewing AWS team members, participants in the hackathon, looking at the prototypes that they're building, listening to that giant bus going by, and seeing how these teams are building the future of VR and XR using the web and the Meta Quest 3 headset. I'm super excited to introduce you to the teams, look at their prototypes that they're building, the experiments that are happening in WebXR, a bit of the keynote, AWS employees, and a whole lot more. So let's get inside where it's a little bit warmer and check out the WebXR Hackathon being hosted here at AWS and our partner Meta.
Welcome everyone to the hackathon. Thank you for being here.
Yay! Yay!
We have an exciting few days ahead, and our awesome sponsors, Meta people,
Yeah!
and AWS people.
Yay!
We are all here to support you.
All right, so the WebXR Hackathon is underway, and inside of this room, keynotes are going on from AWS and Meta executives, talking about how they work together to bring these experiences to the world, the expectations that we have for the next generation of VR and XR experiences, and how to think about utilizing WebXR to deliver those experiences to next generation headsets like the Meta Quest 3.
So we're going to talk a little bit about XR today. I'll try to kind of fly through it, but as you just saw there, that's a 3D interface that's used in industrial space. So we have about 6,800 customers on TwinMaker today, building 3D interfaces, integrating their IoT data, and also working to simulate data as well in there. I'll talk a little bit about the role of XR and what we see going on with AWS at the back end for that. A little bit about myself. I'm Bill Vest. I'm a VP of Engineering. I work on emerging technologies, everything from geospatial to 3D to robotics to quantum computing and quantum networking and things like that. But I am also very much a geek as far as XR. I have one of those Ready Player Go sets where you can run in place. I have the Pro, and now I have the 3, and this is what I was playing this weekend. And that's actually a very cool game. If you haven't played Red Matter, I recommend it. I think there's a lot of potential for it, and a lot of potential in general for 3D processing. So we're seeing 3D processing grow 38% year over year, so it's getting to be a larger and larger market, especially as you see these digital twins being used in the industrial space, simulation, autonomous driving, all those areas, in addition, of course, to gaming. But we're seeing more and more happen outside of typical game use for training and interfaces and maintenance and those kinds of things, and allowing people to do those three-dimensional interfaces. So it's pretty exciting to see what companies are doing there. And I'll give you some examples. And of course, we're partnering with Meta on this, certainly also at the back end with GameLift, as I mentioned before. So GameLift lets you scale your back end to deliver it to millions of customers in real time, right? I think the biggest games we've launched are about 30 million-ish users at a time. And it's very hard to do that yourself. So GameLift just does that scaling at the back end for you. I filmed this in Munich. This is their 3D configurator, which you put an Oculus on and can interface with and design your car and share it with your friends, and you can all argue over what the car design is going to be, or color, or those kinds of things in real time. And of course, they have also the a guy wearing the 3D interface here, being able to walk around the car. So you'll be able to take your BMW and bring it into video games with you now. Your actual BMW specs. So you'll be able to run it in Fortnite, you'll be able to run it in Forteza and things like that. So you'll buy your BMW and you'll get this NFT that's got it all pre-set up for you, which is pretty exciting. So. And of course, we're pretty involved in the open source projects around things like WebXR. We open sourced our O3E engine with the Linux Foundation, so we're pretty excited about that. We see a lot of stuff happening there, specifically around simulations. And it's really nice to not have to pay for a game engine. Another hint there, it's an open source game engine, and you can change it. It does ray tracing, it's nice high resolution rendering. Pretty impressive. And of course, our team is a member of Overture, which is we're working with Meta on, which will give you ideally 3D anchors. It will blend 3D environments. You can imagine pulling in the map of San Francisco and using it for a movie or a video game or a navigation system for a car or those kinds of things as those start to become 3D.
And these three fundamental things are probably true for many of the kinds of things that all of you are thinking about today in terms of what you want to ultimately hack, even beyond the next few days as you develop new experiences over the next months and years. I'm going to talk about embodiment, the sense of actually being in an experience. I'm going to talk about the physical and the virtual world coming together. Some people call that mixed reality. And I'm going to talk about interactions, the way you engage and interact with virtual content. So 3 things. This will be high level. I'm going to move through it quickly, but it'll give you a sense of where things are today, and I'll kind of point to a few things that are coming. Right? This is an avatar. Her name is Aura, what we call a stylized or a fantastical avatar. That's not my dad, right? We're not quite at the point where we can create a truly high fidelity, accurate replica of my father. This is where we are today. In fact, this is available on GitHub. It's using the Quest Pro, a product we released over a year ago, the face tracking sensors, and available through the Movement SDK. You can actually create this today. But it's not my dad. What I'm about to show you are 2 people who are also not my dad. But it's getting close. I think a lot of you have seen this. This is a fairly recent interview between Mark and Lex Friedman. And these are avatars. Super high fidelity, what we call codec avatars. Something we've been working on for quite some time. Not quite available yet. Still sort of a research project, but we continue to make progress on it. This was Mark sitting in Menlo Park, I think. I'm not sure, actually. They may have been somewhere else. And Lex Friedman probably in his studios in Austin, Texas. Both wearing a virtual reality headset, a Quest 3 headset. No, Quest 2 headset, sorry. And running codec avatars. So it felt like they were in front of each other, but these were avatars. They were over 1,000 miles apart. This is a step towards that vision I was talking about being able to go and visit my dad. Now, when people move around, when my dad moves around, when he stands up, we need to track your body. There's sensors on these headsets, as you know. We track your hands. We can track your upper body with those sensors. We can synthesize what the lower body is doing. So this is what we call full body tracking. Again, important to create that sense of embodiment in the environment. I actually did push-ups with the headset on it. It actually tracked me doing push-ups, so it's pretty good. Again, something that's possible today. Let's talk about the physical and the virtual. Bringing in virtual content integrated seamlessly into your physical environment. And the foundation of this kind of an experience is something called pass-through. It's a technology that allows you to see the environment around you, and everybody knows that VR headset is not see-through, right? You have displays, it's blocked. So what's happening here is we have sensors that are facing out into the world and creating a real-time video feed. Now, this is something that we did 4 years ago on the Quest 1. It's grainy, it's black and white, low resolution, but it was cool. People liked it. We liked it. Over a year ago, we shipped the Quest 2. RGB cameras, high resolution, we have color now. It's getting better. And you're going to see, if you haven't already, I imagine most of you, if not all of you, have already tried the Quest 3. 10 times higher resolution on the cameras, great color. We're getting closer and closer to actually seeing the environment as through your own eyes. Getting closer and closer. Now, one of the great things about mixed reality and how those sensors work is that we can actually not just allow you to see what's around you, but give the system, give you, the developer, the opportunity to actually understand what is in the environment. What you're looking at here is a capability called Space Setup, where the sensors and the computer vision algorithms are automatically making sense of what is around you. Where are the floors? Where are the chairs? Where is the table? Where are the edges? It's creating a high-fidelity geometric representation. That's important, because if you as a developer want to put something on top of a table, you need to know where the edges are. You need to know the height of the table. You need to know where that plane is, right? And you can do that. I'm going to give you an example of the kind of thing you can do. This is a clip. I don't know how easy you can tell what's going on here, but this is a physical room that's taking the knowledge of where that furniture is located and planting a garden in the empty free space, right? It's a fun thing to do. I think I cut the clip off a little bit too early, but yeah, I think I did. At the end of this, oh, there, you can kind of see it there. At the end of it, yeah, you can see the sky, right? So Bill, you can see Saturn, right?
That would be cool, and open the ceiling.
Right. And you need to know what's going on in the room to actually make this look and feel really good, right? So this is what we're talking about when we're talking about mixed reality, blending the virtual and the physical.
Years I've been working at a consulting firm, so implementing strategy along with executing design for products for the last year.
Comfortable, let's say, somewhere, and then you have a couch. You want to make sure that you have the right way you put your stuff in your living space. You want to arrange it the exact.
And I am a VR interaction designer, and I'm very good at visual, and I make beautiful slides. Guys, I make beautiful slides. And
doing my master's in human-centered design, so I get fit in as a UX designer who could understand the code. I don't know, probably knitting.
People got burned 4 years ago or 5 years ago, and so they want something that is de-risked even though it's inherent.
My name is Oscar, or Osco, and I like anime, decentralization, and virtual reality.
So those are, they created the WebXR Discord in late 2020. I first stumbled upon Mozilla's Hello WebXR.
The stuff. Yeah, excited to learn, and also I have some ideas about museum experiences.
So then we could actually, I mean, it could be a thing where once you establish one, it kind of like limits your options so that you get through. But yeah, I mean that's kind of optimization. But I like that as a gesture.
Oh, you don't have to actually program.
It's called body therapy, and it's basically like when people are.
So that was my pitch initially, and then you suggested we do like
that is the when people are dancing, they will have the flow of their body. Yeah, and their body movement will be transferred into the visual effect.
Share what kind of technology stack were you using? So I'm the content guy, she's the UX person, so these two are going to carry the whole team. Vue.js? Cool. Nice. Yeah. So we have like one person that's actually still trying to find a team. I think you guys cool to take him in, or he's a Vue.js person as well. Does A-frame mainly, but I'm not a person, but then just like, isn't it now 5? I thought the rule was like 3, ready with 4. I don't care if that's fine.
Some sort of experience where we take like your environment, add to it, and really like use it as spatial like add on to
What would almost be ideal, but again, outside the realms of my expertise, would be almost procedurally in the node model creation, in the sense that if you could spit back that this is a plane that's so many dimensions by so many dimensions, randomly create a building or something like that that falls within those dimensions. There's a D&D map builder which kind of does that, but again it's a procedural node thing that's out of my realm of expertise, so I'm afraid to put that on the table to have someone who takes that down theoretically. But that's another thing that I'd be interested in is kind of to your point, if we can get feedback of once we find that plane data or that geometry data, be able to procedurally make something that can fit on there dynamically, so that if you go into a room that has a small table, you'll have like a small building, whereas if you have something that's big, you can have a big building, and theoretically, I'm not 100% sure how it maps out the room, but no, like, hey, this is like a 2-story, like you can make it huge, or the roof is here, so you gotta make it this big.
It's very challenging, and I would suggest if we do a multiplayer game, we would do turn-based, because that's the simplest, easiest, like, avoid a time sink kind of situation. Like, real-time multiplayer might be too hard for 3 days.
Yeah, I think a lot of the networking stuff just was dealing with whatever final access kind of thing. Yeah, maybe keep the multiplayer side low to light kind of thing. Yeah. Like even if it's part of the experience, you can just have it prototype, hand base on the mechanism behind it. Only focus on things that.
We could do turn-based, and you could do like a turn-based puzzle, like where like one person has to like solve it, and then I'm a game counter sometime. Then whatever was saved before, it's gonna be there. Right, but like our whole game is about random placing things. So do you really?
It doesn't benefit the narrative.
I think so too. If you start the game, yeah, but if you want to resume the game and then you want to start off from where you left off, true. That's true.
It doesn't.
Although it doesn't really make too much sense. Like
that's less to do with the physical anchor location, to do with the state of the game.
Oh, okay.
It kind of sounds like we are just adding that, just add it. Not really we need it.
Yeah, we don't really need it.
Visualize one of the reasons when you guys
the whole thing with like kind of ripple of triangles. It's It's kind of like, you know, when iOS ripped off the multitasking from the Palm Pre, and it's like, wow, this is shameless. Like, that's how that makes sense. So there's this retail idea where it's like, if the employees are just walking around on patrol or restocking or whatever else, can the kind of scene mesh capture enough data about shelves to realize when something is
absolutely.
So either that employee then gets a notification,
This flows
since they're already there.
This flows on purpose.
What is confusing? What's something that you have in your head that's like, I don't know, what's
Yeah, I'm trying to complete the user journey. So like,
so what happens after they do this?
yeah, I'm thinking that first what would the one fly?
Yeah, and that's
because that the one fly would fly.
That's what we were talking about.
From your face and then land to
Right.
That needs the user to hold the camera.
Right.
But they probably don't do. They don't know how to do that.
Maybe
So it will fly in front of you all the time.
Right.
So the most instinctive, yes, the most instinctive thing is that you run. And but if you don't.
Spectrum Sense.
Spectrum Sense. All right, and team members?
I'm Ethan. I'm Ethan.
Ethan?
Zach.
Florian.
Florian? James. All right.
2, 3.
Reality Warpers. There we go. Name?
Daniel.
Brett Williams.
Matt David.
So, your team name?
See Through Sound.
See Through Sound. And names?
Andy.
Steven.
Kelly.
Kieran.
All right. So, team name?
We are Signcraft.
Signcraft. All right. And your names?
I'm Oscar. I'm Bo. I'm Shmoji.
Shmoji. I know Shmoji. It's what? It's
the Reality Rebels.
The Reality Rebels. All right. And your names?
My name's Daniel.
Icecan.
Michael. Rahul.
Flutter Force. All right. And your names, please.
Peter.
And Chris.
Eldertech. All right. And your names?
My name is Rohan. And what's up?
Hi, I'm Avinash.
I'm Simon. Monster Mash.
Oh, Monster Mash. All right. And your names?
I'm Chris. Dayton.
And?
Dayton.
Hello everyone, my name is Kain Hu. I'm a senior solutions architect in AWS, and I'm working with Meta on the Metaverse initiative that two companies partner together. This hackathon, this exciting work hackathon is one of them. And welcome to the hackathon today. Today we are going to provide a workshop that focuses on how to build a WebXR app on AWS. This workshop takes a sample WebXR game built by our awesome Meta engineer Felix. And it learned from the experience and best practice we got from working with a variety of customers that develop XR applications. And we will share this best practice with you today. Here's what the workshop will be about. We've got all the WebXR actions built with JavaScript ready to go. You can play, score, and enjoy the game fully on the front end. But here's the catch. Scores saved on your local machine are as fleeting as cookies in a cookie jar. Refresh and poof, they're gone. Plus, without a permanent home on the web, right? Sharing the fun gets very tricky to people that you want to share and to your friends. And here's that's where AWS whips in. No more playing hide and seek with your high scores or keeping the game to yourself. We're going to show you how to launch this baby onto the cloud, making it public with a URL that anyone can click, and even add secure user login.
Buttons, you also have your trigger, you grip, you can like fine tune them to find like a spot, like 0.5 for example. Yeah, so, and above this, we also have added some keyboard bindings for some popular actions. For example, we have joystick movements that snap to WASD on your keyboard. The right joystick is going to be the arrow keys. We have mapping for the buttons as well. I can't remember all of them exactly at this moment, but essentially you can actually run through a WebXR experience just using your keyboard. This on the left, by the way, is Elysian in action. Yes?
Is there like a video demo for this? Because this is really cool, but I feel like I'm going to forget it all in like 5 minutes.
Yeah, there are. Again, this is the browser extension is actually already launched in Google Chrome web store, and there's a YouTube video I can share in the Discord chat as well. Any like set hand poses, so you can do like a pointing pose and then like have it go to the pinch. Yeah, we can talk after that after this presentation. Yeah. Cool. Yeah. Great. Going on. This is.
Sorry, with that emulator, does that support the web mesh from the rooms game?
I'm going to talk about that in just a second. Yeah. No, like that.
So why do we talk about AWS with XR? Well, we want to scale you. We want to scale how you operate. There are 27.7 million JavaScript developers in this world today, but we only maybe have about 10,000 XR developers. And for us to succeed as a community, we need to basically transform more of those developers from JavaScript to what we do, to doing 3D, to doing 3D user interfaces. Basically, we need to take what was built in game tech and make it easier for everybody to utilize. Everybody kind of get the gist of that a little bit, see that area we're going? Well, definitely a big piece of that is we want to support you. We want to support how you develop. So focusing on open source, all right? Make it free. How do we help you with free things that we can give to you to develop faster, develop quickly, and be able to utilize the cloud to do that? Oh, they got that fun part covered up. So, all right, open source repositories, definitely that. We have multiple open source repositories dedicated to supporting XR type applications, which we'll talk about one or two here today. And then we want to use those to convert or enable you to develop more applications. We get more applications, we get more users. We get more users, we get more feedback. With that feedback, we can build better things for you to deploy XR applications. That's why I'm over here asking what you want throughout this entire hackathon, because I want to know what I need to build next.
Hey everybody, I'm sitting here with Felix from Meta Reality Labs, and we're here at the WebXR Hackathon that AWS and Meta have put on together. And Felix is going to walk us through the IDE that the participants in this hackathon are using to create these incredible experiences through the browser on the Meta Quest 3. So Felix, good to see you.
Good to see you.
Awesome.
I'm excited to be here.
And we're excited to have you here too. So let's go ahead and jump in, and why don't you walk our viewers through this IDE and what the developers are using to create their experiences in this WebXR hackathon.
Yeah. Would gladly do so. So what we're seeing here is actually, well, I don't think we should call it an IDE. It's actually just a browser window with the Chrome DevTool panel open over here, and this is actually just a WebXR game that I had made. Normally, this wouldn't. This is a VR button. When you click on that, you would normally launch you into an immersive VR session if you are accessing this particular game on a WebXR capable device such as the Meta Quest 3 or a competitor device like the Pico 4. However, this is just, as you can see, this is just on my MacBook Pro, and the reason this is working right now is that the immersive web emulator actually injects the WebXR polyfill layer into the WebXR game, which tricks the game to think, hey, I'm actually running on a browser that is capable of delivering WebXR content. How it specifically does that is that it produces a emulated XR device with all the XR device APIs polyfilled. And because we don't actually have a headset hooked up to the controller, what this immersive web emulator does is that it resurfaces the control of the device, such as we have over here 6-degree freedom control of the headsets and the controller nodes, as well as all the buttons, analog buttons, and the binary buttons on the controllers. We surface them in this intuitive UI so that people can actually do whatever they can with the emulated headset as if they are actually in the real headset. So let's jump into VR. So this is actually, if you access the game in VR, this is exactly what you're going to see. We can move our headset as such, and we can also rotate it just like we could if we were actually wearing a headset. We can do the same thing for the controllers as well individually. You can, if you have found a good position, good pose for the headsets and controllers to be, you can actually save them for as your default pose, but I'm not going to do that here, so I'm going to reset it back to the default pose. So that's the 6-degree freedom transform control for the headsets and controllers. Now we can actually move around with the emulated controllers. So in this game, you actually move around with your left joystick like most XR games. So you can just move the emulated joystick around, and it's exactly like you are moving your physical controller, the joystick on your physical controller. And because this is a shooter game, you can shoot your gun by pressing the trigger on your right controller, and we can do exactly that as well. Yeah, that's pretty much how it works.
Yeah, and I have to say, I mean, I went ahead and used, I got a chance to play this in the headset, and it is silky smooth. I mean, it is everything that you're seeing here, but this is all being done through a web browser. Like, how is the web browser able to go ahead and render this type of game? Like, what are the underlying components that are enabling this type of performance, in the browser?
Well, I think that's a really good question. I think a lot of people, when they think about a web game, they automatically associate, running in a browser, a web game, with low performance. But that's actually not the case. Sure, there is overhead when it comes to running JavaScript in a browser environment versus something that's native coming out of Unity on Unreal. However, the gap is really small here. If you can think about it as a two-parter. So once the CPU, on the CPU side of things, once the scene is all calculated and the commands are submitted to the GPU, we're using the same GPU here as a game that's for example Beat Saber. It's the same GPU. It's doing the same thing. So there's no gap here. But on the CPU side of things, there is some gap. I think some of them are the JavaScript overhead, some of them are the tooling gaps. But if you are really building your project mindfully and be aware of those restrictions and try your best to creatively work around those restrictions, the performance gap is actually really small. Yeah. So that's why you're able to see these kind of games, which if I didn't tell you it's a browser game, you probably wouldn't be able to tell. Yeah.
No, I mean, this looks very similar, like stylistically, to several games that I've played on my my MetaQuest rather, at home. But so basically, this is not a web game. This is using web as kind of the container to deliver this content that then is poking right through down to the middle. So it's accessing GPU, it's accessing core memory, it's accessing audio, it's accessing basically all the same things that you would have in a native application with some slight overhead because, as we were talking about, some of the limitations currently today around JavaScript, but this just continues to improve, right, year after year. So the possibility of delivering super compelling experiences through the browser and working on everything from your phone all the way back up to a virtual reality headset is really now present and more available than ever before.
Exactly. And when we're talking about the overheads and the performance slowdowns, we also can't forget that with WebXR you automatically get cross-platform compatibility, right, which is not something that you can say for native applications. You also don't have to, the user also don't have to install or update anything They just go to this website, and if you have to deploy a change today, the next time the users go to this website, their game is automatically updated. So there's a lot of benefits associated with using WebXR to deliver something like this as well. Yeah.
Amazing. Thank you so much for spending time walking us through this. And you can go ahead and actually check this out as Elysian.fun. You can go ahead and click on the link underneath to check it out. Amazing, amazing work. I'm going to jump back in and play a little more Elysian. So we'll see you all in a little bit.
Cool. All right. See ya.
Really visual rendering actually that on my brain right now.
Yeah, if you guys can have
What are we eating?
Snack time. We got some pasta. We got a little bit of salad. We got this little bottle.
That's right, the coolest little water bottle. Wiggle, wiggle, wiggle. That's a fidget spinner and a water bottle, yes.
There you go.
What do we got here? That's delicious, huh? Yum. Sandwich cam.
Could be that her account isn't there.
What?
She made her account. I'll check her.
Oh, okay. There's no reason you should be.
We are room environment. I would say RTC.
And then the idea is with the other hand, we call select start and then it would pin it on the wall, which would then change something.
Okay. Are you trying to draw a screen? Like a window or like a movie or something?
So it's kind of working a bit off of something that he's done in the past, which is like, immersed.
So, start with a problem statement. So, in everyone's work here, there's an urgent need to understand user behavior in immersive 3D world where Google Analytics just doesn't cut it. Page views and GTAG events don't tell you everything you need to know. So, new tools are needed to gather valuable insights about how real people are actually using experiences. So that's why we built Spectrum Sense. It's a spatial analytics tool for the metaverse. Record user journeys through any physical or virtual environment and play back that data in an analytics dashboard to better understand how users interact with their content. This solution works in real-world or virtual settings. It can track headsets or mobile devices, and it can work with hand tracking or controllers. If you imagine a future where XR glasses are common, this really goes everywhere. So, What is the user experience like? So rather than talk about this product in the abstract, we picked a potential customer inspired by our host city, the Seattle Art Museum, and we went to work building a sample mixed reality project for current and future exhibits there. Some great artists up in the corner. So we then added our suite of analytics tools right on top of that experience to analyze user behavior. So take a look at that. Come on. I'm sorry, y'all. It's on YouTube. Oh, my entire.
Google Slides going down.
My entire freaking. Oh, I'm so sorry, y'all.
No, that's not your fault.
It's not live demo, but it's really great.
It only does that when you're doing a demo, yeah.
There's a German term for this, actually. Vorführer effect.
Apple's not fault, so.
Well, yeah, I've got a.
You can say that first.
Yeah.
Goes fun.
Oh, okay.
Either that or it's.
Restart the browser.
Yeah, just restart this one. Sorry, guys. Thanks
There
for
it
the
is.
inspiration.
It doesn't work. Okay, so when you enter the Seattle Art Museum mixed reality experience, you get an AI narrator taking you on a self-guided tour through the experience. You can see we're tracking every hand motion, every head motion you make as you move through this MR experience. And so as I approach another exhibit, more AI narration about that piece. And again, we're just understanding perfectly how I'm moving through this space, and it's really a perfect record of user behavior.
Possesses the sleek appearance of a manufactured object.
So we played with some interesting tech features with WebXR, so like pinning this content to different semantic labels in the room so we can set up exhibits however we prefer. And then as you approach, go ahead, Zach.
Yeah, and we're using as well the anchor system to sort of calibrate, because right now these obviously don't have a shared scene understanding or a shared room setup. But with the anchors, the idea is that eventually we'll be able to share those so we can calibrate across multiple devices.
Okay, so that's all cool, and we think there's obviously a ton of great use cases in like the museum tour world. But I think the important thing is through all that, we actually are tracking and collating user journeys, whether individually or in aggregate. You're tracking head, hands, and controllers, real world or virtual environments, and you can log key interactions and events from the user. So yeah, I think long term, I think all of us could probably agree right now, spatial analytics are a foundational component of the metaverse, and everyone will be using tools like this in the future. If we start building them now, we can increase, adoption and retention on MetaQuest devices and really grow our audience and, get heads in headsets, as we like to say. So use cases, really any VR, MR, AR game or app can employ this. Maybe you're at a trade show or a conference. Maybe you're on a factory floor. There's industrial applications. A whole lot of digital twin opportunities here. And as we just explored, like a mixed reality, physical, virtual museum exhibit.
And we're using the AWS technology to sort of leverage the scalability. Oh yeah, sorry, we were just going to that.
Yeah, no worries.
Yeah, like leveraging the AWS technology to be able to scale the experiences up. So we're using S3 and oh yeah, sorry, you worked on this.
Sure, yeah. No, auto-scale EC2 instances distributed through CloudFront for our backend, for our data backend. That networking is enabled by Elastic Load Balancer. And both apps are hosted. The museum experience and the analytics dashboard are hosted on S3. We originally started trying to use like Lambda functions, serverless stuff to set and retrieve rooms and user session data. Unfortunately, due to time constraints, our implementation this weekend is this week is a little naive, but definitely entirely conceivable that AWS services can underlie the whole stack here. So. Yeah, great to work with you all. That's our presentation.
Thank you.
Thanks for having us.
So in our app, you can have any from one to many virtual computers or streams going to anywhere in your environment, and you can snap it to the walls or bring it to you, and that way kind of the remote working experience is better than the in-office experience. So the innovation and creativity we're trying to create here is kind of the the usage and like a real usable product within the space that gets more people into it. And by doing that, we want to make it so you want to use VR more than you want to do regular computing. And so it kind of helps with the total adoption of the VR and AR experience, and for making the kind of computing bottlenecks or limitations go away. So you don't need physical monitors anymore. You don't need physical computers. You can do it even in the cloud. We could be running it on an Amazon instance or on a desktop instance. So this is our team. So it's me, Matt,
Daniel,
Brett Williams.
and yeah, so we kind of worked hard and put together a lot of this stuff. And what we did was walk through like what a flat screen experience was like and what that would be like if it disappeared, and kind of just let you use AR in the real world to create a new kind of computing experience that wasn't based on physical computers. So a lot of the approach we took took kind of the experience from a normal TV setup or a computer screen setup, but transferred that to WebXR. So we're using a lot of the plane data, and if we had more time, we'd be using the anchor data to keep everything in the same place, so that as you walk in your office, it's already set up the way you want. You can even have different configurations that auto set it up, depending on what you're doing. The nice thing about it is it can also move with you, so the computers can become heads-up displays. If you want, you can just lock them into place. So our MVP automatically sets up your room environment with your spatial meshes and your planes, and the computer, whether one or many in the space that you're in, will pop into view, and you'll be able to use it like you would a normal local computer for the first version, but eventually you'd just be able to use any remote computers as well. So these are some of the similar products that have been on the market and where we modeled them after, and then we'll just kind of show you a real example of our setup. So this is Daniel at his computer, at his desk, and he's able to just move his computers around, automatically snap them to walls if you want to get them out of the way, or if you're sleeping, put it on the roof, and you can just relax. You can also just automatically pull it to you, and combined with hand tracking, it really feels like magic, so you can push it away if you don't want to look at it anymore, or just bring it to you. So we touched a little bit on this already from a strategic impact point of view. Like, our goal is to make remote work better than local work, because I think a lot of the ideas in VR end up with a skeuomorphism view on how to develop apps, and we've all kind of been there before. Like, your notepad doesn't have to have noted lines anymore. You can make it better than the real world. So the idea is, if you can make a better computing experience than the regular ones and a better work experience than working in person, then why would you keep calling people back to the office?
Don't say that here.
So yeah, the way that we did this is all built on from the web technologies. So it uses WebRTC to create a peer-to-peer connection, and has like a little client app running on your desktop, and that helps make the connection between the computer and the remote room sessions, and it works to create a very low latency connection so that it's very usable, whether it be remote or local to your network. And then from the WebXR side, obviously we used a lot of the WebXR technologies, and those would be planes, and we try to get anchors in, but I think we had some trouble with that. But those would be the idea for keeping it in the same position, along with different hit tests to make sure that you hit the walls. We ended up making our own, just because, you know, when you're not happy with something, you want to do it even better. So we built it with the React 3 Fiber, and we use the RATK library to bring in the mesh data for the frames, and then integrated the different screens coming into the view and snapping into the different locations as the user's interactions wanted them to, whether you want it to be in front of you or just go away. Sometimes I never want the screen in front of me. Okay, so on the AWS side, we basically have planned to use the whole gambit. We have Lambdas running to get your computers and what computers are available to you. And then it would use the Cognito setup to do the auth as well as the database for like saving the data and making the connection secure as we're getting the computers, and make sure to securely hash an agreed upon JWT so that it can be manipulated so that all the computers communicate without allowing random people to take over your virtual systems. That's all my time.
Thank you.
Our product in group is called See-Through Sound. This is everybody's names. We're going to get right into the slides. So what we're building is a persistent multimodal annotation anchored to physical space. The idea is anybody that comes along, puts the headset on, logs in the same space, will be able to interact with previous people's annotations. Multimodal, because we're leveraging AWS, some of AWS service technology to interpolate between modes. So if somebody, in this case, we're demoing people recording audio, then they're able to interact with it both with audio or with text. And the concept can be taken beyond just, you know, audio and text. So we've solved a few problems and workarounds based on some of the current limitations of what you can do with spatial anchoring by having an orientation process. It's very collaborative in that right now it works fully. All the architecture is deployed to the AWS account, allowing you to log in, full auth N, full auth Z, make your annotations. The audio is stored in the cloud. The transcription comes back. You know, it's all very collaborative thanks to AWS's technology. And the idea is also it's very accessible because whether or not you can see or hear, you're able to, you know, interact with the content in either modes thanks to AWS or Amazon Transcribe service.
Yeah, so we wanted to have some very simple user interactions. We expect people to kind of treat this like real life, but with superpowers on top. So instead of having all this artificial fancy stuff, we're very simple. There's pass-through, but the key element is the audio discs, also called a record, that represent the messages that users can save and other users can pick up. The idea is for this to be extremely spatial aware. For example, we should be able to have someone understand max occupancy 49 if they click on that spot. And having that geospatial anchor is very important to us. Some of these features did not exactly exist yet in WebXR, so we've done a hack. So you can see some of the features that we've used, and what I'm calling this right now, manual persistent shared anchors. And so what this means is that I put on the headset, and there's instructions in the app to say I must stand right here, sorry Oscar, and then I will reset my, what we call primary anchor, and then the scene is localized. So all of the specific locations of the annotations are persisted across the space. And then it's really important to us also to make this accessible. Like you were saying, we want to make sure that regardless of your abilities, you can be able to access part of the experience. Yeah, so I think for us, what's exciting is that this is a proof of concept of a very important holy grail that I see in mixed reality, which is persistent, geographically located anchors. So it's not perfect, you know, we're doing a little workaround, but I think it really shows the potential and excitement of how we can stretch the boundaries of WebXR.
And the great thing is, the day that that anchor feature does become available on the Quest 3, you can download the previously made local anchors that are already saved in this cloud account, and it'll populate with that geo-awareness. So after this, I invite all the judges and anybody else to come and put the headset on, log in, and leave your own little annotation, and then listen to some other people's, but we'll just let him walk through it right now.
Yeah, I'll just do a little demo while we keep doing the presentation.
Okay, so this is the list of AWS tools and services that we used. The application is designed in a very decoupled way. Each component can function separately and break, and the app will still essentially work. There's the full S3, SPA, static file delivery stack that delivers the actual app experience. You have API gateway that's Lambda backed, plus DynamoDB for the annotation metadata. You have S3 plus S3 triggers, plus transcribe in order to handle the saving transcription and return of the transcription, audio transcription. And then you have all of the other AWS tools that involve static code building. We built everything with CDK. There are definitely more things you could do with it, but if you wanted to, you could dump this into a production account today and launch it, and it would probably pass most tests. So everything we've done is serverless, end-to-end, even the transcription. Authorization and authentication already works. We made logins for all the judges. And as far as no glaring security issues, we improved on the demo code a little bit by making sure each Lambda has its own least privilege for each individual action. But there are definitely things that we can improve. If you all look at the code, it's on GitHub. We could encrypt the S3 and DynamoDB when it goes to production, and instead of storing the audio files based on the username, we could use UUIDs. So there's a few things that can be improved, but it's almost ready for production as it sits right now. Any questions?
Fantastic. Thank you, guys.
Did you get a chance to see what he was doing while I was talking?
Yes. My name is Oscar. This is my teammates of Bo, Ringo, Shmoji, and Missing Yifan, and we are Team Signcraft, which are working on the app Unspoken, which all you do is learn sign language and mixed reality. So let's get started. Here's a cool little diagram of the ASL alphabet. And that's us again. And so it's yesterday, so that's pretty funny. All right, so here's the problem statement that we're trying to solve. So globally speaking, there's about 500,000 people who are suffering from, or not suffering, but experiencing deafness or hard of hearing. So these individuals are unintentionally excluded from a lot of places and interactions that they would otherwise be with if more people knew ISL. And when we looked into this problem, we saw this was like the recurring theme amongst why it's a little bit hard to learn. Unless you have like a very personal reason to want to learn it, it's not really something people normally want to do. So traditionally, we have a lot of YouTube videos and textbooks, flashcards, things like that are great, but they aren't really effective. They're not really engaging. They're not interesting. Since the community of people who know ASL is very small, it's very hard to find other people who you can relate with or practice with. So you get a little bit of isolation. And you don't really know if you're doing the right thing if you're just like mocking people in a video. So what we proposed is having this be solved in mixed reality. So you're going to have different exercises you can do to practice the signs. We're going to link up with other learners in our app, and you get immediate feedback on whether or not you're on the right track for learning. So this is kind of our UX flow for the version 1 of the app that we were looking to do. Pretty straightforward. So eventually you just sign up, go through the tutorial, have a curated feed, and then go to the first scenario. So this is our mock-up here. This would be an example of one of the interactions you would do inside of our application. So you'll see here that you start in a blank room, and all you'll see eventually will be this floating set of letters. In the previous tutorial, you'll learn the ISL alphabet, so you're like, okay, what could this be? And you see it's in the background. Maybe it's a lamp. So you do the symbol for lamp, which is A, and that'll actually spawn the lamp in reality. And you'll go through this exercise a couple more times, so until you have a fully bright room. And the reason we kind of want to do this interaction is we want to kind of communicate what it's like to be someone who is not heard or seen in a sense. So you feel very isolated, you feel like no one can see you. And going through the exercise, just this little thing of learning how to do ASL, you feel like you bond with someone and then they're seen. So it's a very cool thing that we are spinning. So here is our demo. Let us take a look. All right, so let's go. All right, that's me again. All right. So here is the example of the lamp. So here it is anchored in spatial reality. We do the ASL symbol, you get the feedback you're doing it correctly, it shows up, and then it's a little bit bright so you don't see this, but the lamp appears and turns on the light. So yeah, that is one interaction that you would do. And let's take a look at the rest of the slides. So this is our cloud architecture. It's a pretty straightforward deployment which utilizes serverless and is pretty scalable. So the front uses the web UI, which is served by CloudFront, which is actually stored in S3. It goes through API gateway to both fetch different information for the user and also to validate them. And in our future, we have a lot of ways we can go with this application. So definitely we're going to create more learning paths, enable multiplayer to communicate or to connect with other people who are on the journey of learning ASL. We're going to have it so you actually can add new ASL terms within the app, which I think would be fantastic. And at the end, we'll have a public API for you to query what we have built so far, and maybe make your own collections of symbols, like in Naruto. So yeah, that is our presentation. Thank you all for listening.
Hello everyone, we are Reality Rebels, and I'm Rahul, this is Ayaz Khan, and this is Michael. We are missing Daniel, he just had to take an important call. But yeah, our concept was to build a shooter game that could possibly compete with Felix's
Shots fired.
Fighting worse.
So yeah, this is just a prototype that we came up with.
So this is a portal that can be set up on any of the walls. Yeah, and then you shoot through the portal to shoot at the different flying windows. So we have kind of made the behavior very dynamic.
So our original vision for the project was to basically make a two-player game that was networked over WebRTC. And the game would feature basically two people in mixed reality in their play space. A portal would dynamically appear, and portals would keep appearing during the game, and you would have to basically have a shootout with like the person on the other side of the portal. And they would have basically a rendered environment, but your environment would be your living room. Ideas that we had basically when it came to integrating this into mixed reality was to eventually use the meshes of your room as blockers so that you could hide behind your couch or like basically whatever you had available in your room when having this like shootout with someone else. And not only that, but you would be able to detect collisions so that like we could place like little scorch decals so that like basically you could scorch your whole room while having this firefight. The prototype that we ended up coming up with basically used WebXR planes to render a single portal on the wall, and we set up just like a test environment to like shoot targets with your controllers.
Yeah, so you can skim through.
Yeah.
So for the user experience, we wanted it to be as intuitive as possible. I'm pretty sure like everyone would be familiar with the shooting experience, so we didn't want to steer away from the experience. We don't want to make it completely new, completely out of the box that people would feel jarred just starting the game. But yeah, so the base mechanics would be you shoot the target that would score you points, and every target hit would have a collision detection, and the impact would be shown with splattered bullets. So this was the ideal flow that we envisioned with multiplayer features in it, but yeah, you could talk.
Cool. So the tech that we used were 3JS and Svelte as a wrapper. We used Rapier for physics. We ended up experimenting with Handiwork for hand tracking. We had like the idea of maybe like doing like a pose like this if you wanted to have a shootout with just your hands, and then having different gestures for firing bullets. Another idea that we had was like a closed fist and an open fist.
Blasting from the hand.
which we got pretty close to.
Yeah, we got pretty close. So we were able to detect like open and closed fists, and we are actually also able to detect pinches just because of how WebXR works. So with controllers, you have events based on triggers. With in this analogous way, this is very unique to WebXR. So we also have pinches working right away with the same workflow. So we have a video at the end for that.
Yeah. And if anyone doesn't know what Handiwork is, it's basically a program made by one of the people who works at the immersive web group. It allows you to record different gestures and then within your app have event-driven behavior from those recorded gestures.
And then for multiplayer aspects, we looked into RTC multi-connection and WebRTC. So RTC multi-connection is a library that uses a Socket.io server and its own implementation of the Socket.io server to act as a signaling server. And now in the WebRTC, which is a P2P network, data is transmitted between the layers directly. So we wanted to have this two-layer setup so that the local data that needs to be instantaneous can happen over the local network, whereas all the things that need to be authenticated can happen through the backend server. So we used an EC2 signal, EC2 instance for P2P signal. I think for us the main aspect that we focused on was WebRTC signaling server that we deployed on an EC2 instance. The other implementation plans we had was having a leaderboard and following a similar process to what was shown in the workshop, but due to some time constraints, we're unable to directly implement that. And I have a few videos to show how close we got to some of the features that we're working on. So this is a demo of two devices. So one I'm controlling through the WebXR emulator, and then and this is the video shot through the headset. So the black box here represents the headset moving inside the browser. So
So that basically represents the headset of your peer.
So this is happening over WebRTC. So getting the signaling server up was a bit of a it was a difficult task because first of all, based on security, we wanted to use HTTPS. So for that, we had to get self-sign support. So we used a subdomain for that. So we got that working, and then we came across CORS issues. So we fixed that both on the Socket.io server and also on the signaling server. So we got that working, so that's strong, and then we got the WebRTC working. So some of the implementation details also, as you can see, is also working inside the game. So we built the game ground up to have that multiplayer aspect. That's why we could integrate it at this level. And then just to show, it works with hands too. So this is me pinching and shooting bullets at the targets. So and the score keeps going up. That's a presentation.
This is Team Flutter Force, and we built an experience called Metamorphosis, a shared gratitude journey. And I'll just quickly introduce our team. This is Chris, this is Peter, this is Xiangming, and I'm Hua, and also Costanza. So just quickly show you a video of our game or an experience. Quickly show you something.
Okay, so today I'm grateful for Uber Eats because I was craving cinnamon churros, so I went on the Uber Eats website and found cinnamon churros and had them delivered within 45 minutes. And I got to eat my churros.
Yes, that's the first one, and there's another butterfly.
Happy despite personality that this place that real important because life was super delayed today, and I've been sitting in our facility related to San Francisco, that I find this happy, respect,
And you can see that butterfly switching. It's a long video. I just quickly jumping through them.
So essentially, every time a butterfly lands on your hand, you're hearing a message of gratitude from someone.
Yeah.
After the third one shows up, when you listen to that message, show the caterpillar. Caterpillar appears on the tree, and you're able to reach out, grab that caterpillar, and swipe to the caterpillar.
And you will see a swarm of butterflies flying to the caterpillar, which is guiding you to record your gratitude messages.
Let's go to the next video, because this is where.
Yes, and yeah, we have separate videos.
So yeah.
How brilliant we are.
Essentially, yeah, you grab this, you speak into it, speak your message of gratitude, and then once you release it, it turns into a butterfly and joins the rest of it.
Yes.
Yeah, so this is a gratitude journal as a journey. You are, we focused on the journey as you go through the experience. So when you start, there's a butterfly that's in front of your face. There's a single one that pops up, and it'll track you as you go around. So if you move it around, it'll follow you and kind of always trying to be in front of you. When you put your hand out, it'll go ahead and land on your hand. As soon as it starts speaking, 50 other butterflies will pop up. And so now you're encouraged to explore and hear other messages of gratitude. And then you get the swarm that pushes you towards the caterpillar when it's your turn and after you've heard as many as you'd like. And then after that, we have some instructions to how to record your own, and of course the butterfly appears. So we're trying to, one of the things we focused on was trying to guide the user through the experience and be as natural as possible without having to tell them too much of what to expect and what to do.
Yes. So, following Chris, our innovation and creativity is very simple and straightforward because we want to create immersiveness enhanced mindfulness journey, and we want to create. We also want to create. I don't know if you guys played this game. It's called Kind Word. It's a game that you could send messages to strangers on the internet, and they will receive a paper plan with your messages on it, which is an affirmation word or some gratitude word that makes you feel good. And we are creating similar experience that allows you to share gratitude experience with others in a safe space in your own home and using an async way, which is not intimidating for you to listen to other people's messages. And the innovative part is that this is a true immersive experience that screens such as Team Labs experiences can never achieve. And since Chris already talked a little bit about our core interactions like recording your gratitude messages, and you can hear the affirmations from yours and also from others in an async way. The two experience principle that we are applying here is first, we want to create a realistic contact upon the reality through MR. So to achieve that, Chris really did a lot of work to try to create an algorithm that mimics real butterflies flying past in systematic way. So all the butterflies you see in the word it's been calculated in multiple ways to actually mimic the sports path of a butterfly. All this is just to make you feel real in the MR, and we think that's one of the most important experience core that you will focus on MR. And also, we designed another embodiment of gratitude, which is if you stay still, the butterfly will come to you, but if you move, they will just go away. For this interaction, what we want to convey is that we want to create an experience, and the experience is the gratitude experience. And your embodiment in the MR experience, in the MR space, it's the most important thing to make you feel what we wanted you to feel. So that's also another invisible design we're trying to employ in the MR experience. And by talking the next chapter, we are utilizing WebXR to create such a beautiful experience, which is what we call invisible experience for invisible XR experience, but like feel realistic. Do you guys want to talk about
Sure.
how you use it?
Yeah, so for the WebXR, the way that we use WebXR here is, of course, the butterflies are limited to the room within the room that you're currently in. They will land on any spatial anchor surfaces as well as flutter around. And then, of course, with hand tracking, they'll land on your hand when it's still. If you move your hand, they'll follow and land over here. But if you move your hand again, once they've landed, it'll fly away. So that's a way to say, I don't really want to listen to this message anymore. And of course, pass through, so you're still in the room that you are.
Yes. And in the process, we're also applying a lot of AWS services.
Sure. So so all of this is working. Of course, it's served on AWS S3. We use API Gateway and Lambda to allow you to list the messages and get a bunch of messages at the beginning, which are tied to individual butterflies. When the butterfly lands in your hand, it'll load a message from S3 tied to that message. The record is in DynamoDB, and when you make a recording yourself, it will both add a record to DynamoDB and upload the recording to S3. And you can, if that butterfly comes back and lands on your hand, it'll do the process just like any other butterfly. However, if you reload, that butterfly that you just added that message will not actually be live in the system yet. We have a column in DynamoDB for whether it's approved or not, and so there's a separate step for approval. So in testing, it's so that we don't get like just test 1, 2, 3 and blank messages. But so that would be like a future project to add an admin interface for someone to actually go through, review the messages that get recorded and approve them.
So that we could create a safety space that you wouldn't hear anything harmful or like personal attack.
Yeah, obviously we're going to something positive and very true.
Yes, that's the core of the experience. So thank you guys for listening, and I just want to quickly quote a sentence of another Chris. He's not here. Okay, he like during the 3-day of hackathon, he mentioned one word. I think it's really important and very inspiring for our project. He said that the fidelity of contact is always over the fidelity of content. So what we want to create is a high fidelity of contact that you will feel realistic interacting with the MR world surrounding you. Yeah.
Team Eldertech. My name is Rohan. I have with me Simon, Avinash, and Utsav. And we are going to present this project on ScrambleQuest. So let's start talking about the problem that we wanted to focus on. So, we have all grown up with our grandparents, and we have seen our parents grow over time, and we've always seen one of the biggest problems is, eventually people start having difficulties with mobility as any human being, and like start to have problems with like thinking over age. So we really wanted to go and use mixed reality in a way to sort of support people who need it the most, as people who have declining sort of cognitive abilities and like mobility. So we specifically did some research, and we have target users who are people suffering with Alzheimer's or dementia. And some of our research showed that about 5.8 million people in the US, that's like 1 in 10 older adults in the US who have this problem. And about, we also found out that about if you have regular exercise, which is light regular exercise, it could really decrease the time in which the Alzheimer's disease progresses by about 50%. And the dementia risk doubles every 5 years, and we think this is a really important place that we could really use mixed reality to sort of bring something interactive and engaging that people can use to sort of delay this Alzheimer's disease process and get more sort of social. So this is our persona. So this is, for example, this is Meet Evelyn. She's a 68-year-old school teacher who has always been involved throughout her life teaching kids and math, and she's been very interested in puzzles and things like that. But now that she's old, she struggles with memory lapses and has very difficult stuff going on whenever there's a complex task. She also misses going around and teaching kids, and she has, as she's grown old, she's also having problems like arthritis where she cannot easily move and do many things. So she feels really isolated and doesn't have much to do in an interactive way. So for this, we are introducing this new project called ScrambleQuest, and I'm just going to play this video here.
So ScrambleQuest it really is a remarkable fusion of health and technology. It represents a novel approach to gamified health using mixed reality. At its core, it's more than a game. It's really a new tool in the fight against cognitive decline. It seamlessly blends digital with the physical, encourages players to explore their physical environment, to find letters, and then de-scramble them on their table or other surface in their environment, sort of stimulating their a light mobile activity so that they're kind of getting up and moving around but not too strenuous, as well as sort of mentally stimulating, kind of engaging with multiple senses. So it really represents the sort of capacity of mixed reality to blend sort of digital content onto a mundane space, thus sort of reimagining it or reactivating it, especially things like people's home where it's sort of common and they see it every day. We also researched that with dementia, the main sort of gamification mechanics that have the biggest impact are games that involve language, memory, and motion, sort of eye-hand coordination. And so we decided to combine them all into one game. Yeah. And finally, we focused on sort of intuitive interactions since it's an elderly population that we're targeting. So clear instructions, simple controls, as well as creating kind of a variety of difficulty levels with the number of letters, encouraging players to sort of find the difficulty that suits them, their sort of mental capacity best. And then finally, we implemented AWS to sort of capture score tracking so that, or well, I guess that's the goal. And the sort of incentive behind that is to encourage people to sort of track their progress and sort of see themselves improve over time.
So this was all possible because of a couple of new technologies, especially the depth sensor of the new Quest 3 and the walls and the mesh API, so we could detect the abstract objects like these planes, tables, and all. And the enhanced pass-through of Quest 3 was really important in creating the realism. And so we created the whole experience so that the elder people get motivated to move around and walk around their rooms. We can make the words spawn all around, and even as the technology improves, we can even have them inside some closet and all, so that it motivates them to walk around their room, and there's some incentive to do some exercise. So this new technology is, sorry, yeah. Can you sure.
So we have used the best of AWS to kind of do user authentication, data storage and management, and scalable cloud hosting. So I'll start from like scalable cloud hosting. So we hosted this on S3, and what that enables is that so right now we have like limited assets, but in the future we will have a lot of 3D models where you can decorate with virtual objects, and that can be all like hosted on AWS. So that makes it very easier for us to like add new contents, stuff like that. And also for we used DynamoDB for our data storage and management, where the users they can so after they make a word, it gets stored, and then what we want to do is like we want to use that word as an achievement for them and see what what they have created and stuff like that. And also we implemented a simple user authentication, and we also believe that in mixed reality there's new possibilities of new kind of authentication. Some we talked about like some kind of gesture-based authentication where you don't have to really be limited to 2D screens, but like use some kind of your gesture to authenticate yourself, and that's definitely that's something on our roadmap, and that is the best of AWS that we have used.
Thank you.
All right, so we are Monster Mesh, and we've created a metaverse mesh CMS for the masses.
I'm Matt Hargett, founder of WebXR Specialties.
I'm Dayton Kelly. I'm a master's student at UW studying human-centered design.
I'm Chris Johnson, game developer.
I'm Shrikant. I'm a researcher at Georgia Tech.
So first, we want to talk about our vision for this project and this hackathon. So we see a market-changing opportunity where distributed and collaborative AR experiences will engage new audiences and emerge in new contexts and augment existing physical contexts. You can see some examples here. And a technical breakthrough is sparking this new wave.
So by capturing kind of scene mesh fingerprints to the cloud asynchronously, millions of users can scalably experience shared XR visuals globally, anywhere where there is something that matches that mesh fingerprint, and we'll give examples of that in slides that follow. And this is enabled by a kind of a unique combination of the technologies given to us by AWS and the MetaQuest 3's implementation of WebXR standards.
How we came to this idea, we really took inspiration from both keynotes. The first keynote from AWS with the digital twin. We asked ourselves, what other impactful applications are there for digital twins of places and objects? We wanted to search for contexts that we haven't seen yet being applied before. And we also reflected on the Meta keynote from Marcelo, thinking about how can the new affordances of the MetaQuest augment existing spaces and deepen human connection. So we're really trying to push our solution for something that's beyond entertainment, beyond games, into something that can bring a whole new user base through these themes.
So what we put together, our initial phase was really to analyze the scene meshes and the planes to try to develop some type of a fingerprint so that we can have shared anchors in the space across multiple devices. And so we are to the point where we can actually place models, they get uploaded to the database, the actual positions offset by the anchor point that is calculated. And then our final phase is just to get that back down and get it all rendered so any headset can walk into this space, have the fingerprinted object, and make everything appear that was placed. But you could, in the headset, you can actually place objects that are getting uploaded to the database. And so that's where we are right now. The initial phase was really breaking down the data and analyzing for fingerprints. We spent a lot of time on that.
So for the fingerprints that we talked about, we just wanted to see how the mesh that's being captured. First of all, the mesh rendering, every time you set up a new room, it's going to be different each one of them. So we were trying to understand how it's being reconstructed, all the data points, for example. So the example that the image that you see on your right side is like the mesh reconstruction of this exact space, but we just took the output from the room setup out from the quest, and then we try to reconstruct it so that we can see, if we do it multiple times of room setup, how can we find a common space like a fingerprint? So if we can have two different headsets that set up the room mesh, and then if both have some similarities in their mesh, we can just fingerprint them onto each other. In our cases, we are just looking at the planes, the walls, and the mesh intersections. That's the first thing. And then we use that to place objects. Once we place objects, we want to see how that object is coordinated, the XYZ coordinates on the three-dimensional space, how it looks, and then transfer those to the next user. So that's like the fingerprint works so that they have the same coordinates for the objects in the mixed reality experience. Next one. So for this, we wanted to use AWS for the backend, and this is my first time trying to use AWS, and it was really helpful with the demos, setting up how we can store our data. The main thing we wanted to store with AWS is like the objects, the 3D models with S3, and then we sent queries to serverless API to get the model back and place it in our scene. So that was handled by S3 and Lambda. after that, we modified the setup so that we not only retrieve the model, but we also retrieve the XYZ coordinates that's associated with each of the model, and then recreate the SE. So we had to work it out so that we embedded all those metrics with each of the model for each mesh. That's where we use AWS, and then yeah.
Hey guys, we're at time, so
Yeah,
no, so good. Crank through what you can.
Yeah, so our solution is inspired by the Overture Maps Foundation, but for interior spaces, and and distributing that so that anybody that can scan a mesh, be a creator and upload, but that read-only users don't need any kind of authentication to be able to kind of share in those AR projections onto those interior spaces. And leveraging AWS to power our safety model, so the web application firewall, location services, deal with DDoS and all that great stuff, so we don't have to worry about that. That lowers the barrier to entry for read-only users that aren't content creators. And then this is a kind of a diagram of the AWS architecture that we sort of ended up with. And so there's a couple different scenarios. One is kind of imagine or bring your child to work day at Amazon. It starts with the employee or parent capturing a mesh of their space ahead of their child arriving. And then each child can then put on the headset in their parent's workspace and decorate it in some fantastical AR way that is non-destructive because it's all virtual. And then at the end of the day, all the kids can go to each individual room and so each individual kid decorated their parent's workspace. But also with the digital twin, you can also zoom out and see the whole thing and see the whole office wrecked with emojis or whatever.
And for a revenue-driving opportunity through XR is the automotive industry. One example is the fact that sales associates, they want to sell people a car, but they don't have every car in the lot. So what if we're able to show the car through a virtual environment? And it could look something like this, where they're actually able to pick different models to view, change the color, you go on the website, you can build your own new model. You can do it all there in AR.
But more than just the dealerships, taking this up to the automotive companies themselves, and them having their own metaverse mesh content management system, so that wherever there is a raised platform in a dealership, they can project whatever content they want from their CMS, including doing A/B experiments to figure out what makes those car consumers figuratively and literally lean in to the model, and then tune their content and their projections based upon that.
And for our demo, we use the museum as the space, so you can see a sarcophagus as pictured here. If you have time to try it, we have it ready for you guys.
I was going to say, feel free to move your hand a little bit. It should follow.
Yeah, it's working.
Because if you move it too quickly, it'll fly away, and you should try that too.
Yeah, I did. I kind of
Okay,
released a
great.
few messages. Now I'm trying to get the caterpillar.
Okay, so if you see the caterpillar, you just walk up to the one on the branch.
On
and
the
then
branch,
just grab
right?
it with your pointer finger. Or sorry, pinching almost. And then now speak a word of or a message of gratitude.
This is a beautiful application. You did an amazing job, everyone. Very nice.
And Elysian.
Really awesome. Really awesome.
But it's the exact same thing from their angle. For a truly shared experience. This is just one context in a museum to say, but yeah, in our deck we had it for the automotive industry, digital twins. But yeah, this is what it thinks the solution output.
How far along did you guys get with the mesh fingerprint? That's obviously more than a hackathon's worth of.
All right.
Did he did it? Yay, everybody!
That's awesome. Chris, really?
Yes!
All right, nice work, guys.
Saved off mental decline.
like so that like people could dodge bullets.
Right. Right. That makes sense.
But I guess like faster bullets would make sense for target practice. Or...
We also had shields in mind, so strategically being able to place shields across so that it blocks bullets. So because of that, we had to have it in a way that it's actually visible, the bullet.
Like that's the number.
What you doing, man?
Enjoying my 4 monitors on my giant screen.
There you go. We're gonna make sure you never get away from work.
Exactly. I love it.
Either that, or you'll be more efficient when you have to do what?
Hack the planet.
Hack the planet. You know I'm gonna throw a screenshot or something like that in this video, right?
Well, there's a gif of him like leaning out of, I want to say, the cop car, just yelling.
Yeah, he was. He was arrested. Serial killer.
Yeah.
So right now it's hard to put it, but in the future I might be able to.
Yeah, so right now he has set up his own computer, got that connected, and that's kind of what it's like right now.
Understood.
Yeah, no, Matt did probably, I would say 60%.
Nice. And then you guys have created your own room. Once again, thank you so much. I think the quality of hacks that we saw in last 2.5 to 3 days was fantastic. Yeah. I'm sure it was very hard for Dave and Chelsea and like bunch of other judges to be able to figure out who is the winning team. They worked super diligently over the last, I don't know, 1 hour to 1.5 hours to figure out the hacks. And the winner is
Let's go. Speech.
Thank you.
Good job. Say a few words.
Well, we built a gratitude app, so I am very grateful to be up here. And it was really great to meet a bunch of people here. I wish I had more time to meet more people because I guess we were so focused. So I don't know. I'll be around for a few days if anyone wants to hang out. I'm around.
So glad to join such a great team, and thanks AWS and Meta for putting together this event. Yeah, thanks.
Hi everyone. I'm so happy that everyone loves our experience, and I feel like this is a dream come true moment because like I had made so many meditative VR applications, and this is the one. This is the one that actually makes people feel good. That I see the smile on your faces, and that's the most thrilling moment for me. And so happy to see you guys. And if you guys want to hang out, I live in Belleville. Please come connect with me.
I want to thank Chris. This was his idea from the start. I was helping with development, but at the same time, like he told me the idea on the first day, and I thought it was really inspiring. You met both of you, and you had experience with this, and I think we all worked out really well together. We made something awesome.